Thanks for the introduction. For those who know me, I've been spending most of my career time in monogastrics. So every time I come to the ruminant session like this, I meet new people, I learn new things. Just like this morning, also we just heard from Javier, kind of the foundational talk about life start. So I'm going to continue with that, talk about discovery of phytocomplexes in reducing diarrhea in young calves. I'm with a new group within Nutreco. It's called Nutreco Exploration. In short, Nutex. This is a new group set up back in about 3 years ago. Okay, has a very clear mandate to discover and develop novel ingredients, additives, products for our business, for our two large groups. That's just livestock feed, nutrition, and also the aqua. As you may know, that Nutreco has two large groups. One is on the aqua side. Of course, we are on the livestock side. Okay. This team is to serve both businesses. Okay. Right now, we are focusing on two large programs of phytotechnology and microtechnology. This afternoon, I'm going to focus on the phyto side, but for micro, it's really about live bacteria and also those metabolites produced by those microorganisms. Okay. Talking about plant, there's a huge number of plants that can be studied, explored to find the benefits from them. Just there's a huge number there. We are talking about over 390,000 different plant species there. Another estimation is like 500,000. So it's a huge number. We can continue with this kind of work for the coming ages, I think. But just to go quickly, back in June this year, Nutreco opened the Garden of the Future. That's a center of excellence in phytotechnology in Switzerland, where there's a long tradition of studying phytomaterials for human health, and they call that Phyto Valley. So we purposely put the Garden of the Future in that garden. Of course, it's been running since June, so whenever there's a chance, I welcome you to visit that. And where we do everything from the start all the way to the end. That means we start from discovery. Once we identify a plant, we're trying to domesticate that, and we also produce that and process that and supply that to the customers globally. And what we do different here is really it's a long-term commitment from Nutreco by setting up this center in this strategic location. Okay? And we follow the strict discovery process to continuously targeting the bioadditives in the various plants, depend on the target of the business need. Okay? We focus on the host-mediated mechanisms, and by using or leveraging the complexity of plants. And this is a new way of looking at the bioactives because we are looking at the whole spectrum, the whole family of bioadditives in that plants. And as I said, we cover from the very beginning to the production, also to the supply. So with that, I'm going to jump to this talk about the diarrhea in young calves. And this is an example, or this is also outline how we work. First, we, together with our business partner, customers, we identify the problem and also the mechanism behind that problem. And from there, we're going to screen all kinds of plant materials. Once we have more or less an idea of the phytocomplex, and then we move on to do proof of concept studies in various biological models, animal species, and at the end, animals will have to approve if this is the case. This is the outline, this is the model we follow for every opportunity, or every project we are doing. Of course, the one I'm going to talk about is only one of the many things we do, but we follow this model in our daily work. So I'm going to come to the diarrhea in young calves. And most of you are from this area. We know this is an important cause of morbidity and mortality, actually. It affects almost every farm. Okay? Of course, there are many, many factors involved in this diarrhea issue in the calves, but I'm going to focus on the pathogens that are involved. We know there are several categories of pathogens causing the diarrhea. Of course, I'm going to focus on the parasites today, and within parasites, I'm going to focus on Cryptosporidium. Actually, I'm going to use crypto whenever possible because it's a long word. So crypto is what I mean here, about the cause of the problem, also about the disease name. That's also I use crypto. Of course, cocci is another factor that can cause diarrhea in young calves. We have the second set of pathogens, that's the virus. Again, you're aware of that. So we have the rotavirus, we also have the coronavirus. They are causing diarrhea. Last category of pathogens is bacteria. We have Clostridium, we have E. coli, we have Salmonella, etc., etc. Okay? But the focus is on crypto today. This is the more important or the leading cause of diarrhea, affecting 20 to 80% of farms pre-weaning. Okay? And when infection happens, it has a long-term impact on the performance of the calves. And of course, there's a significant economic loss associated with this. And the estimation is about 40 euros per calf because of the infection. Okay. And unfortunately, there's no vaccine or effective antimicrobials to treat the calves. What you see is the diarrhea, this yellow, watery diarrhea. But if you isolate crypto from that, you will notice, so here, I'm not sure, yeah, those circle, those are crypto there, okay, in the feces. Of course, if you look at the gut samples, in comparison with the normal uninfected gut, you lost almost all the villus. Okay, what you see is a villus atrophy. Of course, when you lose the normal structure of the gut membrane or enterocytes, your digestion will be impacted, absorption will be impacted. Then, of course, you have the diarrhea, and then you have poor performance. One other factor is really there's a lasting inflammation going on inside the gut. And we all know that for neonatal calves, they don't have mature immune system yet, so they don't have the defense developed, especially after the new birth. So when crypto happened during this time, basically the calves don't have the defense system to fight it off. So that's why this is so dominant in the field, because of a lack of self-defense. Okay? And this crypto infection will activate both the innate system, also adaptive system. When that happens, of course, the energy and nutrients will be redirected to the immune response, and sometimes this is a very negative. Of course, all those long-term elevation of the pro-inflammatory cytokines, 1 beta of N gamma, TNF alpha, they all have negative impact on the performance. I want to really you to focus on this central piece here about IL-18. I mentioned that young calves lack the self-defense tools to fight off this infection. Under normal conditions, you would see a well-developed IL-18 cytokine inside the tissue that can promote the production of antimicrobial peptides. That's by the calves themselves. But the young calves don't have that yet, or the level is so low they cannot fight off crypto. So that's a central piece of the mechanism, and we're going to work on that, and we're going to focus on that. And so what we're trying to find is the phytomaterials that can be specifically recognized by the gut membrane or the gut itself, the animal itself. By recognizing by the animals, they can activate certain mechanisms that will improve the immune response, enhance their self-defense. Okay, the end purpose is to really reduce the negative impact by those cytokines, but at the same time to enhance the self-defense of the calf itself. So come to the second part, how we screen the candidates for the solution. Okay, we put here like old-fashioned approach versus a new way. Old-fashioned really is just focus on one single compound in the plant. Okay, and often you would start from an antimicrobial strategy. Okay, how we can kill the crypto or bacteria or virus. That often is the first focus. And so the target is directly on the pathogen itself. Okay. Of course, that kind of approach has its limitations there in terms of efficacy, in terms of challenge. From the regulatory side, of course, cost is often higher. Okay. So in short, it's not targeting the animals, while the new strategy, new approach is really focused on the host or the host-mediated mechanism. That's what we do. And basically, it's to modulate the cytokine response and reduce the negative impact by those inflammatory mediators. And the second is trying to improve the capability of the calves to defend themselves. Okay? This is just a diagram to show we start a very large number of plans against the problem we're going to solve, and we use all kind of biological models to narrow down the candidates, also trying to optimize the combination of the different plants if we need more than one plant. And we do more studies, we do more screening, trying to narrow down to the final target. That's the way we work. For this specific solution, and we start from 26 candidates, and we use 3 in vitro models to measure their impact on the inflammation, on the gut integrity, and also to look at whether they will impact the oocyst viability. From there, we came to 3 candidates. Those candidates were further studied in a chicken model where the chickens were challenged with coccidiosis. And from there, we optimized the combination, and we will further test the efficacy of the candidate or the solution in a mouse crypto challenge model. Of course, the final thing is by the calves themselves, where we also test in a crypto challenge model in calves. Just quickly, some examples from the in vitro work. As I said, we start from 26, then we identify 3 candidate plants and to see whether they will impact the cytokines. And from this, certainly, you can tell they impact these 2 cytokines differently from different plants. The same is true for their activity enhancing the tight junction proteins. So each plant is showing some different function. And move to the next section. And we have the candidate. We also did this study again in chickens with the coccidiosis model and trying to see by feeding only one plant or two plants or the combination of three plants, whether their oocyst shading will be different. This is clearly showing you have to have the three plants together to get the maximum reduction of the oocysts by the chickens. Okay, so this confirms our approach, and this also gives us the, I would say, the perfect combination of these three plants. We gave it a code name called Phytocomplex 15. This is not a commercial product name, it's just more our internal code name. Okay. Basically, we are, again, targeting the host-mediated mechanism and trying to improve the digestion, gut integrity, and at the same time trying to reduce the parasite infection. Okay? And this also showing the different plants can cross over, showing a similar response, but at the same time, they also have their very specific functions. And that's why we put these three together. As I mentioned, we are not directly targeting the parasites. Okay, these plants are there not to kill the parasites. It's not about the pathogens themselves. It's rather to promote the self-defense of the calves so they can fight off the infection themselves. This in vitro test showed that by using different levels of the PC15, the oocysts were not killed or impacted. They're still alive. They don't kill them. Okay, then we move to the more animal trial part, directly related to the crypto infection. We use the first study we did was using a mouse model, and this mouse model was specifically developed for the discovery of development of drugs to control crypto in calves. A well-established model. So we just went to the professor at University of Illinois and started this study, first study in mice. In short, we brought in the mice. Those mice are IFN gamma knockout mice. That means they are susceptible to the infection. Under the normal condition, nature, the mice are not easily infected by crypto. But with these knockout mice, they can be infected. Okay. So when they're in, and from day one, they were given on daily basis the PC15, together with their food and water. By day 3, they were challenged with crypto. Okay? And then after that, the daily fecal samples were collected, and also the fecal status or the diarrhea was scored. Okay? By day 16, the mice were euthanized, and blood samples were collected, intestinal tissues were also collected. The first thing is whether the oocyst shading will be impacted. This is really a clear indication. By day 6 or 7 after the infection, the amount or number of oocysts start to show, and there's a huge difference between the infected control versus the PC15 added mice. This trend goes on all the way up to day 10. More or less the maximum number of oocysts shed from the feces, and only half of that were shown with the PC15 group. All the way to the end, by day 16, you see the mice actually are showing their strong defense already. By that time, their own immune system start to work. But still, there's a huge difference between the control and the infected. Roughly by day 13, there's a 70% reduction of the oocysts. Of course, the diarrhea is also very clear. There's a huge difference. You have a very nice reduction of diarrhea when PC15 is fed. And of course, we know when you have less diarrhea, the mice will have a better chance to grow. That's why they lost much less body weight compared to the infected ones. So they grow, okay? Yeah, when the central piece, of course, as I mentioned, is the intestinal IL-18. That's the central piece for self-defense. With the infection, you see a slight increase in the control. But in the PC15 group, there's a significant increase of the level. That means their self-defense capability has been enhanced by PC15. Of course, as I said, with the infection, the gut morphology was severely damaged. The villus basically are gone. But with the PC15, the damage didn't happen. Or the lost villus was restored. Okay? The last piece, I'll move to the calf. Okay, as I said, they are the final judge to see whether this is really working or not inside the calf. And so we did another study together with the group at Illinois, where the same calf crypto challenge model was set up. Very much the same setup. We brought in neonatal calves between 2 and 4 days old. On day 3, the infection happened. Of course, from day 1, day 0, PC15 was given every day. Okay? Again, fecal samples were collected for oocyst shedding, and the fecal consistence was scored. But at the end, they're all euthanized for blood samples, for intestine samples. The results here, and of course, first thing is oocyst shedding. You see, I was really shocked to see this kind of response. Of course, the professor there was also quite impressed with this kind of results because he's been doing this kind of work all his life. We saw a much bigger reduction of the shading. Almost certain points is gone. It's not there anymore. Okay, and also that you can expect the diarrhea was also significantly reduced, and actually the survival rate of the calves was much better because 2 calves in the control group died during the process. We had 5 per group, and 2 died in the control group. Body weight, when the trial started, the 3 groups more or less had the same body weight. By the end, the control was like 50 kilo, and the infect group was 37. And with PC15, you got most of the body weight back. Okay. Roughly, here's the body weight change in the 3 groups. Again, the morphology and was back to normal in comparison with the challenged calves. Yeah, this is the key for the calves to have the normal physiological process in digestion, also in absorption. Of course, that also means the self-defense capability was maintained. Again, IL-18, that's the central piece here. We saw there's a huge increase by PC15 in comparison with the infected, non-treated group here. Okay? The last study we did was look at what's the optimum dose to use this concept, use this Phytocomplex. So we did a 3rd study, same location, same setup. It's only in this case we didn't euthanize the calves at the study end of the study. Okay, and we test the 3 doses here, just to show the low, the medium, and the high, and to see how they impact the response of the crypto infection. The results again showing that there's quite a dose response, clearly showing by using PC15 at 50, 100, or 150, you see a nice reduction dose-dependently about oocyst shading in comparison with the control. Diarrhea, same, not as dramatic as the shading, but still you see a nice dose response on the diarrhea. Of course, the best or the least diarrhea instance was with the highest dose. So there's a nice dose response there. Again, we were so happy to see even at the lowest dose, there's effect on the shading, also there is effect on the diarrhea. And the same thing for the body weight or the body weight change, there's a nice dose response in these calves. So in summary, we have this novel and unique approach to enable us to develop specific solutions based on a specific issue from the business, from the customers. And we focus on the sound mechanism, and also we try to develop a solution with consistent efficacy. PC15 in this case is the solution we have found, and it has shown a consistent impact in the animals in terms of reducing diarrhea, in terms of, the efficacy has been proven in 2 biological models. We used the coccidiosis model. We also used the crypto model. And this has been also studied in 3 animal species: chicken, mice, and calves. The optimal dose was also determined. And of course, everything we do, we focus on the host-mediated response. Right now, we are also working on the issues related to the viral infection and also on bacterial infection. And those are also the big issues, big problem in calves. Yeah, finally, I want to acknowledge that Dr. Hyun Lina Hoi is really a top immunologist at USDA. She has done foundational work, and we have been collaborating with Dr. Vitola at Illinois, and of course, Ella is the representative from our business. Whatever we start, what we do, he's always involved together with our business partners there. With that, I want to thank you for your attention.